Okay, today in geometry, we're going to just look at some more proofs like we did yesterday involving parallel lines. So we're just going to work through a few more proofs together. So number one, this is the picture they gave to me. Given Q is parallel to R, they want me to prove angle 1 congruent to angle 3. So as always, my very first statement is my givens. So Q parallel to R given. And the next thing I know by looking at the picture, okay, I have angle 1, angle 2, angle 3. What I know is that angle 1 and angle 2 are vertical angles. So I can say angle 1 is congruent to angle 2 by that, the vertical angle theorem. I also know angle 2 and angle 3 are congruent because they are corresponding angles. So I can say angle 2 congruent to angle 3 by the corresponding angle postulate. And now finally I can say angle 1 is congruent to angle 3 because I've created a chain 1 to 2, 2 to 3. I could say angle 1 congruent to angle 3 by the transitive property of congruence. Okay. Let's look at the second proof. This is the picture that they give to me. Given N is parallel to M and angle 1 is congruent to angle 2, they want me to prove that P is parallel to R. Okay? So if we're going to be proving lines parallel, I know I'm going to be using a converse of one of my theorems. So again, I'm going to start out with what they gave to me. So N parallel to M and angle 1 congruent to angle 2 given. If I'm going to prove that P is parallel to R, then that would make M my transversal. And so I need to prove that angle 2 is congruent to angle 3, and then I can prove that that line P and R are parallel. So to start out, they tell me that angle 1 is congruent to angle 2. If I am looking at these two lines, okay, M and N being parallel, then this is the transversal that I know for a fact. So on that transversal, I know 1 and 3 have to also be congruent. So I can say that angle 1 is congruent to angle 3 by the alternate interior angle theorem. I need to get 2 and 3 together. Okay, I have 1 to 2 and 1 to 3. I could do a transitive property if I could create a chain here. Okay, I need 2 to be first. Okay, so that I could go 2 to 1, 1 to 3. They gave me angle 1 congruent to angle 2, so I can't rewrite that as far as erasing it and changing, but I can flip it using the symmetric property. So I'm going to say angle 2 congruent to angle 1, symmetric of congruence. Now I can do a chain, 2 to 1, 1 to 3. So now I'm going to say angle 2 is congruent to angle 3 by the transitive of congruence. We said we needed to prove that angle 2 is congruent to angle 3. So now if those two are congruent, then I see that they are alternate interior angles. So by the converse of that, it proves that line P is parallel to R, the converse of alternate interior angle theorem. So remember that anytime I am proving parallel lines, I have to have a converse of one of my theorems. All right, let's look at some more. And these are just like what we were doing yesterday, just more practice. So here they give me that P is parallel to R, and P is also parallel, that Q is parallel to R, and P is parallel to T. So I'm going to write down what they give to me. So Q parallel to R, P parallel to T. And And I could put them on two different lines or the same line. They want me to prove angle 1 congruent to angle 3. So if I start with, let's see, Q parallel to R, then that makes P the transversal I'm looking at. On transversal P, I see that angle 2 and angle 3 are corresponding, so I could say that they are congruent to each other. So angle 2 congruent to angle 3 by the corresponding angle postulate. So that got us angle 3 into our proof. So now I see they told me that P was parallel to T, so that means that Q is my transversal. On that transversal, angle 1 and angle 2 have to be congruent because they're alternate exterior. So I could say angle 1 congruent to angle 2 by the alternate exterior angle theorem. And again, remember, we're always keep in the back of our mind that chain rule, the transitive. So now I see I can make a chain 1 to 2, 2 to 3. And so I can say angle 1 congruent to angle 3 by the transitive property of congruence. And I've proven what they asked me to prove. All right, let's look at one more. So given, look, they give us all kinds of stuff here. Given G is parallel to H, so G parallel to H, measure angle 1 is 122 degrees. Measure angle 4 is 122 degrees. And angle 1 congruent to angle 3. So all of this is given. So they gave us a lot of information. They want me to prove that P is parallel to R. So if I'm going to do that, the transversal that I would have to use would be H. So I would need to prove angle 3 congruent to angle 4 in my proof, because there would be alternate interior and I could use the converse of alternate interior angles. So my goal is to get angle 3 and angle 4 together, being congruent. All right, so let's see. They tell me that the measure of angle 1 is 122. They tell me that the measure of angle 4 is 122. I could substitute, right? Instead of writing measure angle 1, okay, so if I say measure angle 1 equals, instead of saying 122 degrees, I could say it equals measure of angle 4. And I can do substitution because they were equals. So now I've got angle 4 in my proof. I can now change this from angle 1 congruent to angle 4 by definition of congruence. I need to get 3 and 4 together, so I'm looking at, can I do chain rule? Because here I have 1 to 3, here I have 1 to 4. So I could flip one of these. I need 3 and 4 to be together, so it doesn't really matter which one of these I flip, okay? So I'm just going to flip and say angle 4 congruent to angle 1 by the symmetric property of congruence. So now I could do a chain. I go 4 to 1, 1 to 3, so I could say angle 4 is congruent to angle 3 by the transitive property of congruence. Now that I have angle 4 is congruent to angle 3, I can now say that P is parallel to R by the converse of the alternate angle 3 and 4, alternate interior angle theorem. So just remember, anytime you're proving parallel lines, you have to have a converse, and it's what kind of angles did 3 and 4 turn out to be? Alternate interior. So since I proved that angle 3 and angle 4 were congruent, alternate interior angles, that's one of my rules that proves parallel lines. And so the converse of the alternate interior angle theorem tells me that the two lines are parallel. All right, so that is our second day. notes of proving lines parallel using our converse theorems. Your homework is to finish the worksheet from yesterday, the 3.3 proofs worksheet. That will be due tomorrow on Friday.